Hello everyone, this video is about the proof of binomial expansion. This is not actually an actual formal proof. It's more like something to help us make sense of things. So from this formula, this is from the Pure Mathematics 1 binomial expansion formula that we have derived. If we replace the a with 1, so you replace the a with 1, this a 1, this a is 1, this a is 1, we replace everything with 1, and then 1 to the power of whatever is just 1, so we can just ignore the 1 to the power of whatever. So we just have b to the power of 0, b to the power of 1, and so on. And now nc0 is just 1, b to the power of 0 is also 1, so this term becomes simply 1. And from the combinations definition, nc1 is the same as n factorials over 1 factorials n minus 1 factorials, and c2 n factorials over 2 factorials n minus 2 factorials, and so on. And if we simplify, n factorials is the same as n times n minus 1 factorials, so we can cancel out n minus 1 factorials, n minus 1 factorials. Here we can cancel out, and so on. So we have n only, n minus 1, and here we have n minus 1, n minus 2, all the way to 0. And so this is exactly the same. The last line is exactly the same as this first line here. Now when the n equals 3, we have 1 plus b to the power of 3. So we have 1 plus 3 over 1, 3 times 2, 3 times 2 times 1. And here we have a 0. So this means we multiply 0 and 0 times whatever is 0. And this is just 0, this is just 0, so that is why we stop right here. So it makes sense that the 1 plus b all to the power of 3 is equal to this, because we have 0. But if the power is, for example, 3.5, as you can see, it does not stop, because we never get 0. Here we have 1.5, 0.5, minus 0.5. So the expansion continues forever if the power is not a positive integer, because when we subtract 1, subtract 1, subtract 1, we get 0 here. But if it's not a positive integer, we never get 0. So if n is a rational number, we get a sum to infinity. So now from 1 plus b all to the power of 3.5, this is what we get, exactly the same thing as this line here. Now when the b equals 10, so of course 10 is bigger than 1, we have 1 plus 10 to the power of 3.5, and if we use a calculator, we get this. Now if we use only one term, we get just 1, because just the one term. If we use two terms, we have 1 plus 3.5 over 1 times b, which is 10, so 3.5 times 10, we get 36. If we add more terms, so the sum of the first 3 terms, we get this, the sum of the first 4 terms, and so on. So as you can see here, we get, after 7 terms, we get 71,000 something, and the calculator value is 44,000 something. So it's quite far, 71,000, 4,400, so 71,000 and 4,000, that's quite far. But if we use b equals 0.1 instead of 10, this is the calculator value for 1 plus 0.1 to the power of 3.5. And if we try the first 7 terms, as you can see, this is the calculator value, and this is the sum of the first 7 terms. it's exactly the same. So it makes sense that we have this binomial expansion formula when the x, or the b in this case, should be smaller than 1. Alright, that's it. I'll see you again next time.